Hello dear students of plus one medical and non-medical respected teachers. So today I am going to discuss a very important topic of chapter liquids known as viscosity and Stokes law. So let us define what is viscosity first. Suppose we have a liquid say water in a beaker or some container. Let the liquid is set in rotation with the help of glass rod or finger. Then you will see velocity of liquid is found to be maximum at the center and it decreases as we go away from the center toward the walls of the container, and velocity is minimum with the walls of the container. And when this rod is taken out, the liquid stops rotating after some time due to internal opposing force. So this internal opposing force is nothing but force of viscosity. So viscosity or viscous drag, it is the internal force of friction which always tend to destroy the relative motion between the two consecutive layers of the liquid. So this is called viscous drag or viscosity. Now Newton's formula for viscous force. Suppose a liquid is flowing from left to right, and suppose this is the bottom surface of the flowing liquid and this is the top surface. You will see velocity of liquid is minimum or nearly zero just above the ground, but it increases as we go up and velocity is found to be maximum at the top of the liquid. Now consider two layers P and Q, two consecutive layers at distance x plus dx and x respectively. So P is above Q. Then velocity of layer Q will be slightly less than the velocity of layer P. So let V is the velocity of layer Q and V plus dV is the velocity of layer P. Then what will happen? Molecules of layer P will tend to accelerate the molecules of layer Q because their velocity is more. Whereas the molecules of layer Q will tend to retard the molecules of layer P. So as a result of this struggle, they will lose their relative motion. So some force is needed to maintain the continued flow of liquid, and that force is called viscous drag. That force is the measure of force due to viscosity or viscous drag. And according to Newton, this force or viscosity is given by number one, viscous drag is directly proportional to velocity of the layer. So more is the velocity, more is the force required to maintain its flow. Number two, viscous drag is directly proportional to surface area of the layer. So more is the surface area, more is the force required. Number three, F is inversely proportional to distance of the layer from the bottom. So more is the distance of layer from the bottom, less is the force required. So if we combine these factors, so we get F proportional to AB by X. AB by X. Or F is equal to minus eta AB by X, where eta is known as constant of proportionality and it is called coefficient of viscosity. And this negative sign indicates that viscous force or viscosity is of opposing nature. For two consecutive layers, instead of V or X, we can write dV by dx. Where dV by dx is called velocity gradient, which has units of second inverse. So F is equal to minus eta A dV by dx for two consecutive layers like P and Q. Now from this we can define units of eta, or we can define coefficient of viscosity. So if A is equal to 1 unit, say d by dx is equal to 1 unit, then F will be equal to eta numerically. So coefficient of viscosity is numerically equal to viscous force required to maintain unit velocity gradient and area unity, or you can say coefficient of viscosity is numerically equal to the tensile force acting per unit area required to maintain the unit velocity gradient between the two consecutive layers, because this viscous force acts tangential to the surface of the two layers in the opposing direction. So this is the definition of coefficient of viscosity. Again I repeat, coefficient of viscosity is defined as the tangential force acting per unit area to maintain unit velocity gradient between two consecutive layers of the liquid. So in SI system, if F is equal to 1 Newton, area is 1 meter square, d by dx is second inverse, then unit of viscosity will be 1 decapoise. So decapoise is the unit of viscosity in SI system. So viscosity is said to be 1 decapoise when a tangential force of 1 Newton per meter square is required to maintain a velocity gradient of second inverse between two consecutive layers. In CJ system, the unit is poise. So when F is 1 dyne, A is 1 centimeter square, and d by dx is again 1 second inverse. So 1 poise is numerically equal to the tangential force of 1 dyne per centimeter square required to maintain unit velocity gradient of second inverse, 1 second inverse between two consecutive layers. So 1 decapoise is equal to 10 poise. So this is all about units of viscosity. Then we come to Stokes' law related to viscosity. Now suppose we have a medium, say air or water, anything, of infinite extensions. Let a spherical body is dropped into the medium. Then when it comes down, what are the forces acting upon the body? Three types of forces are acting upon the body. Number one, weight mg, acting vertically downward, which is equal to the weight of the body, volume into density of the body into g. Second, ft, upthrust, acting vertically upwards due to Archimedes principle. Due to Archimedes principle, any body falling through a medium experiences an upward force, which is equal to weight of the medium displaced. Third is F vector, force into viscosity, that is viscous force or viscous drag, and by Stokes' law, this viscous drag is given by F is equal to 6 pi eta Rb. F is equal to 6 pi eta Rb, where eta is the coefficient of viscosity, R radius of the body, V is the known as terminal velocity. Now what is terminal velocity? When body is falling down, three types of force are acting, mg, F and ft. Now as body falls, due to gravity its velocity increases. So if its velocity increases, force of viscous nature also increases, as F is directly proportional to V. Ft remains the same if density is uniform. So it means a stage comes when sum of viscous force and upthrust, viscous force F and upthrust is sufficient to balance the weight due to weight of the body. And then body starts falling down with a constant velocity due to property of inertia of motion. And that constant velocity, when F vector, viscous force and upthrust due to Archimedes principle balances the weight of the body, is known as terminal velocity. And that terminal velocity is given by F is equal to 6 pi eta Rv in accordance with Stokes' law. Now to prove this Stokes' law, we can use method of dimensional analysis. It states that if force depends upon three factors, coefficient of viscosity eta, radius of body and velocity of the body. So F is equal to K eta power A, R power B, V power C, where A, B and C are the dimensions of eta, R and V respectively. Then write dimensional formula on both sides. Force M1 L1 T minus 2 left hand side. K constant, no units. Eta, coefficient of viscosity, has dimensions of m1, l minus 1, t minus 1 power a, radius l power b, velocity l1, t minus 1 power c. Now simplifying right hand side, m power a from here only, l power minus a from here, plus b from here, plus c from here. So l power minus a plus b plus c. T power minus a from first term and minus c from last term. So it will be t power minus a minus c. Now comparing powers of ml and t on both sides. So we have m power 1 and m power a. So a is equal to 1. The value of a comes out to be 1. T power minus a minus c is equal to minus 2. So it means c is equal to 2. C is equal to 2. Value of a 1. 2 minus 1, that is 1. C is also 1. We can simplify it. Then minus a plus b plus c is equal to 1. Such the value of a and c, you get b is equal to 1. So f is equal to 6 pi eta rv, because value of a is from experiments is equal to 6 pi. So substituting these values, we can find in this equation, we can find viscous force. So we can prove the Stokes law by method of dimensions. Then expression for terminal velocity. So very important topic, that when force due to viscous nature and upthrust due to Archimedes principle balance the weight of the body, body starts falling with constant velocity. That constant velocity is called terminal velocity, and terminal velocity is given by, so that expression we have to derive. So in equilibrium, when body is falling with terminal velocity, so F is equal to F plus Ft must be equal to mg. दोनों upward force the sum weight mg बराबर होना चाहिए, where Ft is equal to weight of medium displaced, so which is given by 4 by 3 pi r cube volume of medium displaced into d density of medium into g, equation number 4. mg weight of body, spherical body, volume 4 by 3 pi r cube into rho density of body, material of the body is equal to into g. So this is fifth equation. And by Stokes law, F is given by 6 pi eta rb, and substituting values Ft, mg, F in equation 3. So we have 6 pi eta rb plus 4 by 3 pi r cube dg is equal to 4 by 3 pi r cube rho g. Simplifying it, 6 pi eta rb is equal to 4 by 3 pi r cube common, rho minus d into g. So pi cancels, this 4 cancels 2, and here we have 6 3, so 1 r cancels, so v is equal to 2 by 9. Simplifying, r square rho minus d into g upon eta, very important expression for terminal velocity in accordance with Stokes law. So v is equal to 2 by 9 r square rho minus d into g upon eta. Again, r the radius of the spherical body, falling body, rho density of the material of the body, d density of the medium in which body is falling, g acceleration due to gravity, and eta is the coefficient of viscosity of the medium. So it means terminal velocity is directly proportional to square of the radius of the falling body. It means more is the radius, more is the terminal velocity. That's why small raindrops acquire very less terminal velocity and large raindrops acquire more terminal velocity. So ਨਿੱਕੀ ਨਿੱਕੀ ਕਣੀ ਦਾ ਮੀਂਹ ਪੈਂਦਾ, ਪੂਰਜੀ ਪੈਂਦੀ ਹੈ, ਉਹ ਬਹੁਤ ਵੈਲੋਸਿਟੀ ਘੱਟ ਹੁੰਦੀ ਹੈ, ਪਰ ਜਦੋਂ ਮੋਟੀ ਕਣੀ ਦਾ ਮੀਂਹ ਪੈਂਦਾ ਤਾਂ ਵੈਲੋਸਿਟੀ ਬਹੁਤ ਜ਼ਿਆਦਾ ਹੁੰਦੀ ਹੈ. Number 2, v is directly proportional to rho minus d, difference, the difference in density of the body and density of the medium. Now rho minus d may be positive. When it is positive, if density of body is more than density of medium, the body will fall, so terminal velocity will act in the downward direction. But when rho minus d is negative, velocity will be upward instead of downward. The body will acquire velocity in the upward direction. That's why air bubbles in a bottle containing soda water rise instead of falling, because of rho minus d is negative. Density of air bubble is less than that of soda water. This question may be asked. Third is v is inversely proportional to eta. So more viscous is the liquid, less is the terminal velocity, and vice versa. So जितनी viscosity ज़्यादा होएगी, उतनी body terminal velocity घट होएगी. इस करके same body, spherical body, when falls in air, velocity ज़्यादा होएगी, water जो उसको velocity घट होएगी, and like material like liquid like charcoal, ये लोग कहने अपा, कुछ velocity बिल्कुल zero होएगी, बहुत because viscosity बहुत ज़्यादा होती है. So this is all about viscosity and Stokes law. Be happy, all the best, good luck.